Hey Math 1B, this is part 2 of the 3.5 lesson. How do we multiply values in scientific notation? So really, really big numbers with really, really big numbers, or vice versa, small ones. And how do you divide numbers in scientific notation? So before we jump into the examples, I just wanted to kind of show you how does this have any bearing on like maybe real life scenarios. And I went to Khan Academy. I kind of just searched, hey, are there any word problems where you use scientific notation? And there are tons in physics. So if you see this one right here, it says the speed of light is 3 times 10 to the 8th power meters per second. Which is basically a really, really big number. The speed of light's really fast. If it takes 5 times 10 to the, I believe that's the 2 power, for light to travel from the sun to the earth, what's the distance between them? So distance equals rate or speed times time. So I guess what they're saying here is that you could take a really big number times another relatively big number. And if we knew how to multiply values in scientific notation times each other, then this calculation could be way quicker than it is. Now it ends up that in this particular case, it works very similarly to how powers worked when we did exponent properties. What I mean by that is, consider 3 times x to the 8th power. So I'm kind of going off trail here. And I'm saying, let's consider something structurally very similar to this. And then multiply that by something structurally similar to that. So the question I have is, do you still know how to take 3x to the 8 times 5x squared? If the answer is yes, then you are halfway there pretty much. 3 times 5, x to the 8 times x to the 8. All I did was use the commutative property to rearrange things. 3 times 5 is 15. X to the 8 is 10. Remember, x to the 8 times x to the 2, you add the exponents. 10, the 10 power is now the x. You do the same thing here. You're going to rearrange it so that the coefficients are side by side. You're going to rearrange it so that the 10 powers are side by side. These 10s are basically just like x's. It's just we know they're 10s. This will be 15 times 10 to the 10th power. And then there's one more move we need to do. In order to put it in scientific notation, that number needs to be between 1 and 10. Right now it's out of bounds. So what you would do is you'd say 15 is the same as 1.5 times 10 to the 1 power, right? 1.5 times 10, that gives me 15. So all I'm doing is I'm rewriting it as a coefficient that's between 1 and 10. And then what I do is I say, I now have a very similar situation that I had here, where if I'm multiplying 2 powers of the same base, they both have 10s, I add the exponents. So my final answer on this one would be 1.5 times 10 to the 11th. So all this to say that when I'm multiplying amounts in scientific notation, I multiply the coefficient times the coefficient. I add the powers of 10. And then I got to do this move where it seems like all I did was take the decimal point, move it 1 to the left, and that created an extra power of 10 over here. So let's see if we can't work our way through those examples. So my first example, multiplying 2 amounts in scientific notation. It's going to be 4.8 times 6 times 10 to the 4th times 10 to the 6. Take your calculators out if you need to and multiply 4.8 times 6. That ends up being 28.8. Multiplying powers of the same base means add the exponent. You get 28.8 times 10 to the 10. Be sure to rewrite this as 2.88. And it seemed like we added a power of 10 every time we had a bigger number. So that's going to be the same thing here. It's going to be 10 to the 10 plus 1 power. You can almost think of this as 28.8 has an excess power of 10. You guys know what excess means, right? Too much. So we give away that power of 10 to this group right here. So I don't know if that's helpful, but that's kind of the way I see it. All right, why don't you guys pause the video and try B, C, and D on your own. All right, let's check them. 7.5 times 3.2 is 24. 10 to the negative 15 times 10 to the 37 is 10 to the 22 power. Your job is to take the decimal point. Even though it's not listed here, it's technically 24.0. Move it once here, you get 2.4 times 10 to the add 1 power because it has an excess, right? 10 to the 23. Down here, take 1.45 times 7.2. I don't have that one committed to memory, so I'm going to use my calculator to check this out. It's 10.44. So the coefficient starts out at 10.44. 10 to the negative 6 times 10 to the negative 5 is 10 to the negative 11. I still have an excess, all right? It's bigger than 10. So I'm going to move the decimal place once to the left. And that excess or surplus is going to add 1 to this right here. Now keep in mind, negative 11 is kind of like saying I'm in debt 11. If I add 1 to it, I'm now only in debt 10. So just don't be careless with your calculations. Make sure you guys are still recognizing, like, if you add 1 to a negative number, the digit actually gets smaller. All right, and then the last one over here, 2.06 times 5.5 ends up being, I think it's 11.33. Let me double check, though. $11.33 times 10 to the 4 plus negative 9 is negative 5. We have a surplus or an excess, so what you do is you say, I'm going to move you over here, and then I'm going to give that power back here. 10 to the negative 4. Now again, I could do a Khan Academy video where we do an example where it's dividing, but you know, I think I'm just going to bypass that and say the only difference between division and multiplication is that you're now using the exponent properties for division, and your coefficients are literally dividing themselves. So you're going to divide 4.2 by 3. So you're just going to calculate that. 4.2 divided by 3 is going to be 1.4. You can plug that in your calculator to check that out. The power of 10, all right? So that's how you deal with the coefficients. The exponents, 10 to the 5th divided by 10 to the negative 3. The rule was same base when you're dividing powers means you subtract the exponents. So it's 10 to the 5 minus negative 3. So 5 minus negative 3 is positive 8. Because that's how subtracting negatives work. Since that number's between 1 and 10, you're done. It's in scientific notation. Let's try it with this one. You're going to literally take 1.76 divided by 2.2. You get exactly 0.8. Now the powers of 10, you are going to take negative 28 minus negative 5. So it's subtraction now. You're not adding the exponents, you're subtracting them. So negative 28 minus negative 5 is negative 23. And now we have a number that's not quite between 1 and 10. So what we have to do is we have to borrow a power of 10 to turn 0.8 into 8.0. So borrowing is like subtraction. And the only reserve we have for numbers are right over there. So it's kind of like, hey, I borrowed 1 power of 10 from somebody that already owes 23. So if you borrow from somebody who owes 23, they now owe 24. So yeah, it's basically like division usually creates subtraction both places, right? It creates subtraction of these powers, and then if you get a number that's out of bounds, it creates subtraction of the ultimate final answer. So why don't you guys pause the video, maybe, hold on here. Let's freeze that, erase this, pause the video and try C and D on your own. All right, let's see if you guys are right, and then we'll call it a lesson. You take 7.05 divided by 9.4, you get exactly 0.75. This is 0.75. The powers of 10, 10 to the 32 divided by 10 to the 16. Remember, you are subtracting those exponents. You should get 10 to the 16 power right here. We don't have enough to be between 1 and 10, so you're going to move the decimal place over 1 spot. That gives us 7.5 times 10 to the, we had to borrow a power of 10 from that group right there. So you subtract and you go down to 15. And then our last one, you're going to take 2.04 divided by 3.4. We'll use our calculator for convenience. 0.6 times 10 to the, well, this power is going to be 10 to the negative 41 over 10 to the positive 32. You should be subtracting those exponents because that's how division of powers works. Negative 41 minus 32 is negative 73. Wow. Okay, so it's sort of like this power of 10 owes 73. I still need to move this to make a number between 1 and 10. This turns it into 6.0. And I needed to borrow from that group of negative 73. So it owes 73. Well, now it owes 74. All right, that's all I got. Thanks for watching, guys, and hopefully these two parts of scientific notation clarified things for you. See ya.